Hello students, today the lesson is Huffman coding based image compression algorithms. In image compressions, we discussed already different types of image compression algorithms. That is lossless compression algorithms, lossy compression algorithms, everything. And in this, there is a lossless compression algorithm. So Huffman coding is one of the lossless compression technique. Okay, we study this all things detailedly. Now we will have one problem in this Huffman coding algorithm based. Before going to solve the problems, we will take one simple recap on this Huffman coding algorithm steps. How to compute the Huffman coding algorithm based for the given symbols. So if you take any source which may emit different symbols with symbol probability values, okay, so symbol with the symbol probability values, the first step is, so we must arrange all these symbols based on their probability values in a descending order. Second, the last two symbols in the descending order, the last two symbols we have to add, which gives the new symbol, that is a compound symbol. The last two added symbols will form a new compound symbol. Then in the third steps, see, adding last two symbol which gives the compound is second step. The third steps we have to follow the same, that is the second steps, until we get last two symbols. Okay, that is the third steps. So after that, we assign binary codes to the symbols. That is the code word assignment steps. In code word assignment, so we are assigning binary codes 0s and 1 from last two symbols to the all the symbols. That is in backward manner. So we start from the smallest source and work back to the original source. That is the last two symbols to the all the symbols. From that we will find the code word to the each symbol. So let's see this Huffman coding for the given source with one example. See here I have given the problem. The problem is calculate the efficiency of Huffman coding for the following symbols. So we are going to calculate the efficiency of the Huffman coding algorithm. The symbols given here is A1, A2, A3, A4, A5, A6, and it is given each symbols with their probability values also. Symbol A1 is 0.1, A2 is 0.4, A3 is 0.06, A4 0.1, A5 0.04, A6 is 0.3. So if we add all these symbols, you should give the value should be equal to 1. That's the correct. Okay. Suppose some type of problems, because in this problem they have given symbol with their probability values. So it is easy to move on. In some cases, they will give us symbols with certain details. Like for example, so they may give image. So image means that we will understand that it is basically matrix. So each pixel may have some light intensity. That is a pixel value. So they will give you one image with its pixel value. From that pixel value, you have to calculate what is the probability of each pixels. That is a grade level values. Okay. If you get a problem like that, after calculating all the probability values of the pixels, you have to add this all the values. the value, the summation of this, all the probability values should be equal to 1. If it is not equal to 1, so somewhere else you have done some mistakes. Okay, then you have to recompute, you have to do the these probability values calculations again. That's why I say that it's a shortcut. If you have probabilities, you have to add that all the probability values that should be equal to 1. Okay, now we will move to the construction of a Huffman coding tree. See that for the given 6 symbols, what is the first step? We already discussed in the beginning of this presentation. The first step is, so we have to arrange all the symbols given in a descending order. See that I arrange all the symbols in the descending order of probability values. Symbol A2, which is having higher probability values, 0.4. A6 is the next greater value, 0.3 in the source set. And A1 is 0.1, A4 is 0.1. So here that is your options to keep A1 or A4 in the order, because both are same in probability values. And followed by A3, which is equal to 0.06. The last one is A5, which is having a probability of 0.04. And here you can notice that the symbols of probability values are in descending order only, but the source symbol order is different. Okay, we should not mind that, because from the source, which is coming first is A1, next A2, A3, A4, A5, A6. The source emits these 6 different symbols. Okay, the symbol order is A1, A2, A3, A4, A5, A6. But here we are considering which symbols are coming, which symbol occurs mostly from the source. That is what we say we calculate as a probability. Okay, the occurrence, number of occurrence. That is the frequency of the symbols. That is what we say probability values. These probability values are arranged in descending order. So this symbol order is different. So we should not mind this symbol order. That's why the symbols are this symbol orders are different. Okay. The first step what we have studied is arrange all the symbols in a descending order. See that highest value to lowest. Okay. Now next one is, so there I said step 1, step 2 is that is a procedure. Here I have given step 1, 2, 3, 4 is that is the last 2 symbols we are going to add now. So based on that I have given it. Okay. See that is step 1 here. The last 2 symbols. See that which are the last 0.06, 0.04. That is A3, A5 symbols of probability values, isn't it? So these 2 symbols are I am going to add. See that here a symbol which is having higher probability values, I assign 0. Symbol which is having a lesser probability value, I assign 1. See, in this case, you may assign in 1 and 0 also. That is some logical things. If some message or symbol occurs, so what is the information in it? So generally, if the symbol is having higher information, probability values is less. Okay, and the symbol is having lesser information, probability values is maxima. Okay, so here I assigned 0.06. That is higher probability values. So I assign 0, and A5 symbol is 0.04. Probability values is less, so maybe higher information. So I assign it as a 1. Okay, you may take 1 and 0 also. No problems, no issues. See that by combining these 2 symbols, we get one new compound symbol. Okay, see 0.06, 0.04, which gives 0.1. Okay, see in this, if you are making one new compound symbol, that is probability values added. Okay, again we have to compare this probability values with the existing symbol values. See that 0.4, 0.3, 0.1, 0.1. So we have already 4 symbols. The last 2 symbols only we added. Okay, and the result is one compound symbol, which is also having code word probability is 0.1. Okay, so some cases this added symbols probability value may be greater than this existing probability of the symbols. In that case, again you have to make symbols reshuffling. That means again you have to rearrange all these symbols in descending order. Okay, that is very important. So now we got a 0.1. Okay, so which is not greater than the existing symbol probability values. So that I didn't, there is no need to make a descending order, that is a reshufflement again in this. So 0.1. So here in different color, I just I want to highlight it. See here, 2 symbols added. Okay, which is highlighted. So we got 0.1. So now we have totally 5 symbols. At beginning it is the 6. Okay, now it is 5. 0.4, 0.3, 0.1, 0.1, 0.1. Okay, so what is our second step is what we discussed in the procedure is we have to add the last 2 symbols until last 2 symbols only. So now I am adding this last 2 symbols 0.1, 0.1. And I get a 0.2. Okay, see that, check the existing probability values 0.4, 0.3, 0.1, but the result is 0.2, so which is greater than the existing. So we have to do the descending order again. So now 0.4, 0.3, the compound symbol is 0.2 and the existing probability is 0.1. Okay, see that from here it is the same, continuous. Here also same order, here also same order, here also same order. Here after this addition of 2 last symbols, 0.4 is still in top, 0.3 also top, but because of last 2 symbols added, we got a new compound symbol which is 0.2. So that after this reshuffling, that is a descending order, this is 0.1 which is we got is A4. Okay, see here it is very important we have to keep the trace, because after the last steps we have to come back. That is, we are going to trace. Based on the trace only we will assign the code words. Okay, that's what I am making here. Okay, see here the trace is now in the descending order. Symbol A1 goes down and the compound symbol is in the higher order than this 0.1. Okay, see here this compound symbol I assign 0.1. Here also see that now again I am going to add the last 2 symbols. Okay, 0.2 and 0.1. So the 0.2 I assign 0.1, it is a 1. So after addition I got a new symbol, compound symbol, which is having probability of 0.3. And I compare here we have a 0.4 and 0.3. New compound symbol also 0.3, which is not greater than this existing. So that the same order we keep 0.4, 0.3 and the compound symbol is 0.3. So now we have 3 symbols. So until only 2 symbols, we have to follow this addition of last 2 symbols. So the last 2 symbol is 0.3, 0.3. So the summation of these two will give 0.6 probability values. And if we compare in existing, 0.4 is left, which is less than this 0.6. So now it is in descending order reshuffled. See that? So 0.4 comes down and the compound symbol probability value is 0.6, which is on top, 0.6. See that in this process we cross the off the way. So last we have only two symbols left. 0.6 the code 0.6 is the compound symbol. 0.4 is A2 symbol probability values. Then you can see that from A2 I just trace here. So then I assign 0 and 1. Okay. So half of the coding process is over. Now we have to assign the code word to the symbols. So from the last two again to the source we have to come backward. So backward code word tracing method. Okay, so by tracing these probability values we will assign the codes. So here 0.60, 0.4, 1 I assigned. If I trace 0.4, which is actually not a common symbol probability values, it is originally from the A2, so that I change the color for the sake of understanding this trace. See here, just a minute. From here I am tracing. Okay, so now you will get a clear idea. So that see here, A2 takes only one bit, that is 1. Okay, that's why I assigned here 1. So the first one is here A2. Okay, so its code is 1. So that I have written here the code. So this all after that all these steps I have given another one column code. So another one is a length, that is a code word length. Okay. So A2 symbol takes the binary bit 1. So here I put 1. Here the symbol order is A2, A6, A1, A4, A3, A5. Okay. The same way I just encode, that is I assign codes to these symbols. So 1 is A2. Okay, in this order, in this code order only, here code words are given. Okay, so now see that 0.4 is assigned to A2. So one symbol got a code word. Next is 0.6. 0.6 we didn't get 0.6 directly from the any one symbol. It is a compound symbol. So which leads to the code word assignment to all the remaining 5 symbols. So here we have to trace carefully. Otherwise we may commit some mistakes in the code word assignment. See that 0. Okay, so 0. Now we are coming here from here to here. Okay, 0. So there we have again 2 branches. See that from this 0.6. So 0 is there. Again, if we come here, 0 and 1 is there. So now first I take a first branch, because here we have 2 branches. No? So I take a first branch. So 0 and 0. Okay, so we go in this way. So if I go this way, going back, which gives A6. Which gives A6. So that symbol A6 is taking 0 and 0. Okay, so 0 and 0. So this 0 is the first, this 0 is second. See that A2 symbol length is only 1 bit, so I assign code word length is 1, and the A6 symbol is 2 zeros are there. See here we should not think 2 zeros, 3 zeros, whatever it is only 0. Okay, but code word, while doing code word, Value of a digit is not important. What is the number of digits? That's important now. So 0, 0. So 2 bits assigned. So that I take the code word length is 2. See that first one trace, second trace over. Again we will go to that 0.6 which is having one more branch. Okay. So 0. Now coming 1. So here we have I change the color. So in this branch, if I trace, again we may have some other branch. Okay. So I just trace. Is there any symbols directly related to that? So there is a possibility. If I come in this way, there is one more symbols. You can complete the code word assignments. So I take here this way. That is A1 symbol. So that from here 0, I start here 0. Okay, see 0. So I have written here first 0. Next one is 1. So I have written 1. In prefix order, you have to write the bits assignments. What is the first is 0, and in the prefix that is next is 1. Okay, now coming down another branch which gives the 0.1 which is directly to the A1 symbol. So 1. So that now we got a 1, 1, 0. That is the binary bits we assign to the A1 symbol. Okay. So A2, A6, A1. 3 symbols finished. Okay. Now we'll go to again. See that the compound symbol 0.6. Through that we got 2 symbols coded. So now I change the color. Okay. If we come 0.6, we come here. 0 tree branch already over, and 1 is here, and here 1 already finished. So 0.2, that is 0 here, it is left. Okay. So now I follow from here. Okay. So that 0 coming here. Okay, 1. So here 1 minute. So I just write the values here. 0, 0. Coming down it is 1. See the order 1. Now we are following in this way. Okay, so that okay, so 0, 1. See that 0, 1. Here 1, 0 is there. So 0, 1, 0. We are coming here. We have 2 branches. In this one branch goes to directly a symbol which is that is A4 symbol. So there is 1 0. So that it is 4 binary digits assigned. See that A4 symbol which is having a code word of 0 0 1 0. Total 4 bits. So that you have to write 4 in this code word length. For A2 1, A6 2, A1 3, A4 it is 4 values. Okay. Now last left is 2 symbols, A3, A5 only. Again I am going here 0.6. I take another one. Yes. 0.6, 0. Coming down here, this branch closed 1. So 1 branch I am taking 0. Okay, here coming. Okay. So here in this 1 branch closed, 0th branch is now going. In this branch, 0 is closed, 1 is left. If I come, here we have a 2. So now it is closed. So what will be the code? So that it is 0 here. Next it is 1. Here it is 0. Coming down, it is 1. Again the same 1. Okay. So code word length is 5, bits is 11010. Okay. The same way we just trace the code. Dear students, please kindly check it. Here one mistake is there. That is, it is a 0. Okay, so it is a 0. Okay. Now the last symbol is, that is left is A5. Again we will code this A5. So I take another one color. Yes. So from here start 0. It is to work. It is not easy to follow. Yes. 0. Okay. 1. Coming here. Okay. So 0. 1. We come here. So 1. Okay. So that 1, 1, 1, 1. It's 1 minute. So the code is 1, 1, and next is 0. Next one, last one is 0. So I think we should not get any confusion here. Here I just follow in this order also. You can trace here also. So generally we should avoid the confusions in this way. So 0, 1, 0, 1, 1. So this is it, final. So that here I think we have to be in this steps. I think in these steps we just miss the order. It is actually 0. That is what is that A4 symbol. A4 symbol, see that 0 from here first. And next is 0 coming here, 0. So what is that? 0. Next 0. Here it is a 1. Finally 0. So symbol order is 0, 1, 0, 0. This order. Okay, I just change the order. That's why this mistake here. Please omit this. Okay. So finally we got coded all these symbols. So code here in this column, code word length is also there. So 1, 2, 3, last two is 5 symbol, 5 in length. Okay, we will move to the next slide. There we will do the computations of remaining values. So that here to compute the average length. What is the task is we have to calculate the coding efficiency. So for that we need to calculate what is the average length of the code words. Okay, the formula is average length L is equal to sum of products of these two values. That is the probability of the symbol with its code word length. So I have taken the code word length 1 and the symbol probability is 0.4. So we know which symbol is having 0.4. Next symbol is 0.3 probability values. Code word length is 2. And 0.1 code word length 3. 0.1 4. The last two digits, two symbols which is having code word length 5. And its probability values is 0.06, 0.04. Okay. So by substituting all these symbols probability values and its a code word length, we will get what is the average code word length of this source is 2.2 bits per pixels. So this source need minimum 2.2 bits per pixels. Okay, if you take a one symbol, at least it needed 2.2 bits average in average. Next is to compute the entropy. That is, what is the average information in the code words. Okay, so that is the source. So the symbols emitted from the source, what is the average informations, that is known as entropy. So we can calculate H of S, that is entropy, from the formula. So probability of the symbol log base 2 of probability of symbols. So I take here all the 6 symbols 0.4, 0.3, 0.1, 0.1, 0.06, 0.04 probability of all the symbols, and it's the logarithm values. This logarithm is base is 2. So how to calculate logarithm of base 2 is, so calculate, suppose I am taking 0.4. Okay, so 0.4 log. So log 0.4 divided by log 2. If you calculate in this way, you will get what is the answer for log base 2 of 0.4. Okay, so like that I calculate all the symbol values, which will give entropy of this source. Now we got what is the entropy of source is 2.14 bits per symbols. Okay, the last step is to compute the efficiency of the Huffman code we generated. What is the efficiency of the Huffman coding system? Here we discuss. So that is given by the formula eta, that is efficiency, is equal to H of S, entropy over average bit length, average code word length. Okay, what is the H of S? We got here it is 2.14, and the average length of the codes then is 2.2. So that I got it is 97.27%. You have to multiply it. And if you do multiply by 100, you will get percentage. Okay. So the answer for this Huffman coding system is 97.27. So that is the coding efficiency of the Huffman coding algorithm here. Okay, student. Now we have seen that Huffman coding problem with one example. So next session we will see with one more problem. Thank you.